Step 5.2, distance-based methods. We want to look at hybrid approaches now, and in specific we want to look at the two-step clustering approach. Two-step clustering has been introduced for IBM SPSS, and it's available there in a specific implementation. Here we want to illustrate the key ideas between two-step clustering, which combines partitioning methods with a hierarchical clustering method. So the first thing we're doing is we apply a k-means clustering to our data set. We're setting a random seed because we want to run k-means, which uses random initialization. And what we are doing is we run k-means clustering for 10 different random initializations for a rather large number of clusters. So here we select k in a way that it's much larger than the number of clusters we would expect to find, but this allows us to reduce the dataset size. So the advantage of partitioning methods is that they scale much better for large data set than hierarchical methods. So the idea is two-step clustering can come in very convenient if you have large data sets where you couldn't directly apply hierarchical clustering. So we are running this now with 30. We don't think we'll have 30 clusters. This should be larger than the true number of clusters. And if we look at the solution, the plot of that object, which is a KCCA object, where we also add the data, will give us a plot where we have the data points, and we have the centroids. So here, these nodes here, this indicates the position of centroid 1. So we have 30 nodes, and each represents one of our centroids for our 30 cluster solution. And these are graphs because we have edges in between. Edges indicate closeness between centroids or clusters, in the sense that if there is a link, observations in that cluster have the other centroid as the second closest centroid. So we see there are no edges between the three true clusters we have in our data set, but we see that each of the true clusters has been split in much smaller clusters, much smaller units. We see the data points are colored in the different clusters, and we also have the hulls indicated. You can slightly see them here. So what the idea is now, we replace sort of all the observations here assigned to cluster 1 by their centroid, and only remember the centroid and the size of the cluster, and use this information for hierarchical clustering. So in a sense, we are using the centroids to hierarchically cluster the data and look, can we find a structure there? Are we able, if we combine the centroids stepwise, to find the 3 cluster solution in that? So that's the next thing we're doing. We are extracting the centroids using function parameters. So this gives us now a 30 times 2 matrix which contains for each of the 30 clusters the values on the 2 dimensions. And we also calculate the size of each of the clusters using getting the cluster assignments and tabulating them. So this is a vector of length 30 containing how big are these, and this we can use with function hclust, the hierarchical clustering function. We calculate the distance matrix using Euclidean distance between the centroids, and we also include, so this gives us a 30 by 30 distance matrix, and for each of the 30 dimensions we include with members the information how many observations are sitting behind that row or column in the distance matrix. And this is a convenient, this function members in hclust allows sort of, if you have started hierarchical clustering and you cut, you could continue from that point on, given the distance matrix between the groups you have already created and the group size information. So we are running hierarchical clustering now and plotting that with main equals empty string. We say we don't want to have a title. This will give us now the dendrogram And using the dendrogram, we should now be able to see is there a cluster structure. We can remember that the height indicates what's the distance at which these two are merged. So we see there's a big increase in distance when we merge those two clusters together, and then also when we merge the third cluster together. So the decision would be on 3 clusters if we look at hierarchical clustering here. And if we decide on the 3 cluster solution, we can use the function two-step to obtain now the clustering for the original 500 data points. So this uses the information from the hierarchical clustering and the cluster assignments from the 30 cluster solution from the partitioning method. And we say we want to cut sort of the hierarchical clustering object at to get 3 clusters, and then we look up in which observation is in which of the 30 original clusters to then obtain the final cluster solution. So this is now a vector of length 500 containing 1, 2, 3, and we can see that we were able to reconstruct the 3 cluster solution which contains 200, 100 and 200 observations.